out. So, okay, so Asaf Pras, our next speaker, is a Ph.D. student here at Tel Aviv University. Give him a big round of applause for that. Thank you. Okay, that's patriotism for you. He's also the founder and CTO of DataPond. DataPond, you want to know what it is? So it's a company that develops systems for real-time monitoring of water quality with special focus on microbial contamination. And the company's technology is based on research conducted, again, here at Professor Adas Maman's lab in Tel Aviv University. Asaf is going to tell us about the real-time, in-situ, monitoring of water quality systems. So please, Asaf, and thank you so much for coming here today.
So I must say that it's really flattering to talk after Google and Microsoft representatives. So a big pleasure of mine. Thank you. So, as we mentioned, and thank you for the introduction, I'm going to speak about real-time and in-situ AI-based water sensors, which is part of my research that is being conducted here in Tel Aviv University. And based on this, we have established the company of DataPond. So after speaking on so many crises worldwide, I will take us and specifically we'll talk about the water crisis. So water crisis is real, it's here. And it's already impacting billions of lives worldwide. More than 2 billion people around the world lack safely managed drinking water, with more than 700 million people live without basic drinking water services. This means, as you can see in the picture that we took, this was from Tanzania, people are drinking directly from the surface water itself. If it's from rivers, you can see here from some kind of a pond. And eventually, this leads to an astonishing number of more than 800 children under the age of 5 that die daily only because of drinking unsafe drinking water. So in order to tackle and to reduce these numbers, first of all, we need to understand where is the problem, when it occurs, and why it occurs. And for this, we are having water quality monitoring. So obviously, water quality should be routinely analyzed, and this is mainly done actually for decades, if not for more than that, mostly in labs. There are numerous numbers of parameters that can be monitored in real time and in situ these days, specifically the more basic ones, pH, electrical conductivity, dissolved oxygen, etc. But the most important parameters still cannot be tested and analyzed in real time and in situ. And this means that people get the data and the information that the water is not safe for drinking only hours and up to days after they drank the water, meaning that they're drinking, and only after they are hospitalized, we tell them you shouldn't drink it. And specifically, we set 2 goals to address. The first one is the bacteria or the microorganisms, and the second one is the fluoride. So the first goal, as I mentioned, was fecal coliform. Fecal coliform is the bigger group of indicators of microbial contamination in drinking water or in water in general. The WHO, World Health Organization, set the limit to be no microbial appearance in drinking water, meaning 0 mpn for 100 ml. Just to understand, the traditional test with the Petri dish, as you can see in the picture, takes between 18 to 24 hours until you get the results, and this excludes the time that it takes to sample the water, to deliver it to the lab, and to deliver back the result. Again, after you drink the water, only a day at least after that, you will be notified that you shouldn't drink it, and you know what happened in that time. Now, again, because of the long process, and this is also quite an expensive process when you take into account that you need to do it for each water network, and not only once, but multiple times for each water network. These kind of tests are being conducted only at the best cases, maybe in Israel, which is one of the leaders of the water quality worldwide. So here it happens once in a week. In most places, it's being conducted once in a month, and in rural places, it can go up to once in every 6 months. So water is not the only thing that is scarce in this sector, but also the data. So it might sound like not a lot. I know that when you talk about floods, you have like millions of data sets, but also in floods, you don't have a lot of floods themselves. So in this case, we're able to get, and this is a different topic that we can talk about 85 observations of water quality tests, including 55,000 samples of microbial tests. Again, this is not something that people want to share. Utilities, governments are not willing to share, but we were able to get it in purpose of research. Eventually, after a long research, this is not the initial results, this is the final results. We were able to come with a binary classification solution. And the idea of the binary solution is to address the problem, the fact that the problem can be divided to absent and present of fecal coliforms in the drinking water. And this is exactly what we've done. We based the whole models on some water quality parameters that can be tested in real time and in situ, such as the temperature, obviously, the pH, the TDS, DO, etc. And in order to characterize the water, or at least this is what we hypothesized, we also added what we call geographical parameters, such as the location, not in a term of a 12-digit GPS coordinates, but in a more general way of term of location, and also the type of the source. So we will be able to let the model to learn the pattern and to characterize the water, how it should be look when it's called clean, and how it will be tested when it's not when it's polluted or contaminated. And the results are quite good, let's say it like that. More than 92% of accuracy and sensitivity, which was the metric that we were trying to optimize in terms of keeping the public health. We actually were able to minimize the false negative to about 2%, meaning that only in 2% of the occasions where our model says that the water is good to drink, it was actually not good to drink. This obviously can be even more extremely go down up to almost zero, but of course this will take all kinds of metrics down with it. Now, again, we hypothesize that we are able, or not we, the model is able to characterize whether the water is safe to drink or not safe to drink, and eventually fecal coliform is a numerical value, which means that it has a load, okay? It's not a 0 and 1 as we simplified it. And the next thing that we wanted to see is if the disruption of the water, the contamination gets bigger, and the disruption gets bigger, is the model actually able to see it better? And this is something that we can see here. So for a really low contamination of between 0 to 5 fecal coliform load for a term of, thank you, for most probable number for 100 ml, the model drops to 81% accuracy, but as the contamination goes higher, we are able to predict and to give a nowcast with better accuracies up to 90 and more than 95% when the load gets higher. And this led us to the thought of another part of the research that is being conducted nowadays. Are we able to predict not only the binary answer, but also a multi-class answer according to another standard of the WHO? In this case, it's the risk category. Each risk category is correlated with, let's call it a higher or lower impact on the human health. And we can see that we get quite good results. Again, this is for a 5 classes multi-class model, more than 72% of accuracy. On the edges of the very low and the very high, we see that we're getting more than 80% of sensitivity in those classes. But at the middle, we're still not there. Although you can see that when you go plus minus 1 risk category in each category, we're accumulating to more than 80, 90%, which means that in our feelings, we're on the right way. But still, this is an ongoing research, and hopefully we will be able to make it work better. This obviously needs more data to be fed in order to do so. And both this and also the binary model is actually being tested and implemented nowadays throughout India. Maybe I haven't mentioned before, but in Israel, it's not a good idea to conduct this kind of research, because in Israel, the water is quite good, okay? It's something that is kind of unique to the world. In India, we get a better ratio of contaminated water and not contaminated water, and this is why it was easier. But obviously, we are working to implement the same technology also in Israel. And it will take time, but we will get there. The second goal, as I mentioned, is the fluoride levels. So high levels of fluoride it results in dental and skeletal fluorosis, deflection of the joints of the legs and hands, and also the back, and all those black dots and this is fluorosis dental, black dots on the teeth. And again, the WHO has a standard of 1.5 milligram per liter. Above that, it's said to be contaminated and not appropriate for drinking. And so again, we try to simplify this kind of problem and look at it as a binary classification problem, if it's above or below. In this case, traditional testing methods are happening in the lab. There are methods to do it in the in situ, in the field, but they're quite expensive. And we tried in some term to use the same method that we use for the microbial contamination prediction based on the same sensors, so we will be able to give more data from the same data that we're collecting. So in this case, we are based on a different data set of groundwater samples, more than 150,000 observations, and I'll rush through it because I'm running out of time. Eventually, we were able to come up with a bagging model that was able to predict almost 85% of accuracy with different numbers of sensitivity and precision. This is also an ongoing research, only at I won't say at the beginning of it, but at the middle of it. Hopefully, we will be able to make it higher. And that's it, on time. Questions?
Are there any questions? Please.
How reliable possible on occasion not finding
Yeah, so the question was how reliable are the datasets? Well, because of today, the golden standard of water quality testing is done in the laboratory. We are addressing the dataset as the most reliable data source that we have. Obviously, there's a lot of problems with this kind of datasets. I'll say that the water sector is quite traditional, maybe too much traditional. You know, a lot of processes are not automated. So we do find a lot of problems in the dataset. We clean it, obviously. That's why we have, I go back to the microbial dataset, we had more than 85,000 observations. We used less than about 55,000 of those. Not only because it wasn't containing the target that we are looking to solve, the fecal coliform present or absent, but also because a lot of mistakes and probably other things that happen to the data. But it's also easy in the water quality sector to know when the data is not reliable, even because some parameters should be in some kind of a range. And you can also see that if some parameters together are showing different, they're not correlated between themselves, but they are supposed to have some kind of a range if the water is really clean, or if it's, let's say, sewage. So if it was something that shows that it's probably sewage water, we obviously took it out. Yeah, so so who are the end users? So I wish the end user could be every water user, which is everyone. This kind of technology, again, when you're looking at developing countries, it's not something that is affordable for every user. But obviously for water utilities, for water suppliers, those are the main, yeah. No.
Obviously on the dating app, but frame it as a regression problem. Around, take it as a multi-class problem and sort of wrap it to use the binary and see how that fares.
Yeah, so that's a good question. So first of all, the data can be addressed as a regression problem. Again, that's in like the high end of the complexity of this kind of problems, and it's some kind of an overkill in this kind of problem. Again, we are trying to tackle it also as a regression problem, but we will need more data than what we have. This is specifically the problem with this kind of solution. And the second question was about, sorry?
So yeah, so essentially thought for the regression, but also multi-class.
Oh yeah, so we are using the basic binary answer as an input for the multi-class problem.
I thought the other way around. Like,
Yeah, no problem.
Thank you so much.